Greetings everyone, Cup of Science Joe here. Today, I would like to talk about infrared imaging and telescopes. To get us started, we should ask, what is infrared imaging? Well, IR, or infrared imaging, is the process used to detect electromagnetic radiation that is emitted in the infrared wavelength. When we place the technology to do this into a telescope, it doesn't differ significantly from the way a reflecting telescope works when designed to observe light in the visible wavelength. Here we have the electromagnetic wavelength spectrum. As humans, we're capable of seeing in the visible light band. And just to the left of it here is the topic that we're covering in today's video, the infrared light band. Now you may wonder, in what ways can we benefit from viewing infrared light in astronomy? While there are a number of examples, my favorite one comes to us in the way of distant galaxies. You see, as the universe expands, it stretches the wavelengths of light along with it. This process is known as redshift. The further away an object is from us, the more its light will have been stretched by the time it reaches us here on Earth. Enter infrared telescopes. Now, infrared light has much lower energy than light found in the visible part of the spectrum. This presents all infrared telescopes with a challenge, namely coming down to the instruments being used. The instruments being used to detect the infrared light must be kept at a cooler temperature than the light that they're trying to detect. Otherwise, the image would be blotted out by the heat of the instrument itself. Earth-based IR telescopes face a secondary challenge in that they need to be raised to a certain elevation, usually on top of a mountain, because water vapor in the low Earth atmosphere is really good at blocking the incoming infrared light. And so by placing these observatories on top of a mountain, we can locate them above where most of this water vapor sits. Let's go over a couple of infrared telescopes now. For the first one, we jump to Mount Graham in southeastern Arizona, home of the Large Binocular Telescope. This observatory has instruments that can view in both visible and infrared light bands, but today we want to focus on the ones that can view in infrared. The Large Binocular Telescope has two IR instruments, Lucy 1 and Lucy 2. These instruments are not only capable of spectroscopy, which I want to cover in my next video, but they can also both image and view in the near infrared bands, spanning from 0.89 to 2.44 microns. Now I must say I would be remiss not to mention our current cutting-edge space-based IR telescope, the James Webb Space Telescope. James Webb is located about 1 million miles away from Earth, orbiting in what is known as a Lagrange point. James Webb happens to be in L2, the second of these Lagrange points. The JWST is equipped with 5 high-resolution and high-sensitivity instruments that allow us to view exclusively in the infrared portion of the spectrum. These include NIRCam, the near-infrared camera, NIRSpec, the near-infrared spectrograph, MIRI, the mid-infrared instrument, FGS, the fine guidance sensor, and NIRISS, near-infrared imager and slitless spectrograph. These instruments allow us to view objects that are too old, distant, or faint for previous space-based telescopes such as Hubble to detect. Let's take a look at some images brought to us by the James Webb Space Telescope. I hope you enjoyed this video and maybe even learned something today. And as usual, I implore you to step outside tonight and look towards the stars.